Alright, in this video I'm going to show you how to solve a system of equations using the elimination method. It's my favorite method. I think it's the easiest one to use, and I'm going to show you why. So I want you to take a look at this system that we have right here. Notice that we have two different equations that are written in standard form. So if we wanted to use substitution, we would have to solve for y for at least one of these equations. If we wanted to do graphing, we'd have to solve for y for both of these equations to put them in slope-intercept form to graph. So the easiest thing to do is use elimination, which means we're going to eliminate one variable. Now looking at this right now, we're unable to eliminate a variable. But what we want to be thinking about is what number can we multiply to an entire equation that will allow us to either cancel out a x or cancel out a y. So me just looking at this, I see that 3 and 9, and you could have used the x, but I'm going to use 3 and 9. As soon as I see 3 and 9, I say, well, I recognize that I can just multiply 3 by 3, and that'll give me a 9, and I could cancel these two out. So what I'm going to do is I'm going to rewrite this. So I'm going to go ahead and rewrite it so you can see what I'm going to do. So I got y equals 4x plus 9y equals 9. Now I'm going to multiply this top one by 3. And I'm going to multiply the entire equation. So here's the key though with elimination. You can't just multiply by to the variable that you want to get rid of. You have to multiply the whole thing. So I'm going to say 3 times x. That gives me 3x's. 3 times negative 3y gives me a negative 9y. And 3 times negative 6 gives me a negative 18. Now if you look at this, I can treat this as individual math problems from top to bottom. So I have negative 4x plus 3x. That's going to leave me with a negative x. I have positive 9y minus 9y. That's going to leave me with 0. And then 9 minus 18 leaves me with a negative 9. So if I rewrite this a little bit cleaner, I'd end up with negative x is equal to negative 9. At this point, I can simply divide out my negative sign, which is negative 1, on both sides. And that'll leave me with a positive x is equal to a positive 9. So I have used elimination to eliminate the y variable, and I ended up with x is equal to 9. So now that I know that x is equal to 9, I can plug that into either equation and solve for y. So I'm going to go ahead and plug it into this bottom equation because I think that's just a little bit easier one to use. So I'm going to say x minus 3y equals negative 6. So I'm going to substitute 9 for x. Minus 3y equals negative 6. So if I work this out, I'll subtract 9 from both sides. I end up with 3y is equal to negative 15. Divide out my negative 3 to isolate my y variable, and y is equal to positive 5. So now I have found my solution set. So if I write this as an ordered pair, I have 9, and then my y value is 5. And that is my solution. Now, just as with substitution, we do want to verify our answer. We want to justify it. So we're going to use this solution set of 9, 5 in both equations and make sure that it makes a true statement. So we'll use the top one first. So I have negative 4x plus 9y equals 9. So that's negative 4 times my x value of 9 plus 9 times my y value of 5 equals 9. So if I do 4 times 9, it's going to give me a negative 36. 9 times 5 is going to give me 45. That's equal to 9. And if I take negative 36 and positive 45 and combine those two constants, I'm going to end up with 9 is equal to 9. And that's true. So far, we're looking good. So let's go ahead and test this in our second equation. So I have x minus 3y equals negative 6. I'm going to substitute my x value, which is 9. Then I'm going to substitute my y value, which is 5. And that should give me negative 6. So if I distribute my negative 3, that becomes negative 3 times 5 is 15. And negative 6. 9 minus 15 gives me negative 6 equals negative 6. That is true. I've checked my answers and justified my work, so the solution set is 9, 5. So I think if you notice, I got to the solution set pretty quick using the elimination system. I think it was definitely quicker than trying to convert both of these to slope-intercept form by solving for y. So this is my preferred method to use, but sometimes just keep in mind, especially when you get to college, they're going to ask you to use a specific method for a specific problem. And I may do the same, but now you know how to do elimination.